So we established the API working group to allow our partners to start to test the API, of course, and then also provide input on the API design, help us think through any new functionality and what we should prioritize in terms of development for a pretty wide range of applications and different types of partners, and then help us with testing and review of the documentation to help us spot things that we thought were clear but might need a bit of additional detail to make it easy for users to start working with the API and use the API to accomplish the things that they're trying to do. We're starting here for many of you with providing early access to the API, which allows you to retrieve and evaluate the data directly. If you have questions or thoughts on recommendations, of course, we'll accept those during the working group meetings, but please also feel free to contact us via support@openetdata.org. That's the best way to reach us. We are still in development mode and supporting a pretty large growing community of API beta testers. So your patience with us as we try to respond to everyone is sincerely appreciated. We will have probably 2 to 3 additional API working group meetings prior to launch just to review the functionality, review the documentation, see if there are any final recommendations or things we need to address before we publicly release the API later this year. And we are also asking each of you to share results from the analyses you're conducting. So let us know how the data is looking, if there's any places where you see evidence of any potential bias in the ensemble ET values or the ET values from any of the individual models. And we're also asking you to check back with us before you use the information in any decision-making process, or if you're conducting comparisons with other data sets before you present that to other groups. So we do want to have the opportunity to just take a look and offer some thoughts and recommendations on the analysis or results, and to help you interpret any surprises that you might come across. At a really high level, the API, well, first it follows the OpenET API specification. So we have a user authentication layer, which Jody will talk through. The geodatabase APIs, they're primarily to handle time series requests from the pre-computed summaries for each of the field boundaries that are available through the Data Explorer. And then the raster API provides the flexibility for interfacing directly with those gridded 30-meter data sets. The original data sets at the 30-meter by 30-meter resolution. That supports retrieval of daily, monthly, and annual data currently. The geodatabase API is limited to monthly and annual data retrievals. We do use a authentication system based on token-based authentication credentials, so we don't have to store passwords or any information about the users other than their email account. And then we have a graphical user interface currently built on OpenET API, and later in the year we'll be adding a custom reporting interface, which will be an even more user-friendly graphical interface for interfacing with the API, and will make it easier to do things like upload shapefiles and draw and store different regions of interest, and then generate reports without having to go directly through the API. But the API was really developed to support programmatic, automated, machine-to-machine retrieval of data, and to allow data from OpenET to be embedded in other software applications and workflows. So I covered a bit of this already. Again, the raster API is to either get subsets of the gridded data, to retrieve data for a pixel or polygon or multiple polygons at daily, monthly, and annual time steps. If you need to retrieve a full time series or a subset of the gridded data files for archiving, raster API is the set of API functions you'll want to use. It's going to return data either as JSON or CSV for pixel-based queries, or places where you're asking for a summary over a polygon or region of interest. And it will return either GeoTIFF or a link to an Earth Engine asset for polygon-based queries. So if you're actually asking it to retrieve the gridded data, you can either retrieve it as a GeoTIFF or as an Earth Engine asset. Geodatabase API should be used to retrieve data summaries and time series for those predefined geometries or for individual fields. And that will allow retrieval of data for a feature or a collection of features, as well as for an individual polygon. But it'll be limited to retrieval of time series data or summaries calculated over a date range. And that's going to come back to you either as a GeoJSON or a CSV. And again, that's just going to support monthly and annual data at this time. There are a couple of different ways to make the API request. There is that default, well, it used to be called Swagger, I guess now OpenET API, graphical user interface. You can, of course, write scripts, which is probably the best way to interact with the API via command line interface or via a scripted a tool that runs on a cron job. And then also you can use different types of third-party graphical user interfaces. So all of those are possible currently. Wanted to highlight just a couple of guidelines before we move into a review of the functionality. One, we have set user quotas for the API, and that's to be sure that the API continues to be efficient and responsive for a rapidly growing number of users. Again, if you run into any problems or the quota isn't large enough for your use case, please email us at support@openetdata.org, either for assistance with quotas or review of code to make sure that the queries are written as efficiently as possible. We are really lucky to have support from the Google Earth Engine team. They've been contributing all of the compute resources as an in-kind contribution to OpenET so far, but we want to continue to be good partners and be respectful of the fact that Earth Engine is a shared community resource and used by probably guessing tens of thousands, if not getting close to hundreds of thousands of users. So we want to be sure that we're efficient with the code and queries that we're writing. I do want to flag that data should be considered preliminary and is subject to change until we have the public API release later this year. We're currently updating a couple of the models and we'll be rerunning data through the winter and into the spring. So data values will change. We're not expecting major changes as a result of these updates, but you will see some minor changes. And again, a reminder to please share those results and key findings back with us, especially prior to use in any reports or presentations or used for any water resources management applications, decision-making or planning. And then we're currently providing data primarily for the purposes of review and evaluation. And most of our use cases are focused on win-win applications. And that's really our priority for supporting users, places where we see that data can be used to improve the management of the resource for all users in a basin. And then finally, just want to say this once more, data for 2016 through 2021 will be updated once more. So please be looking for that change. Don't be surprised if values change here between February and April this year. Another thing I want to flag is that the crop type information that's available through OpenET is that's from publicly available sources, just being provided for interpretation purposes only. So if you are planning to conduct a summary of the data by crop type, it's recommended that the user should provide the data or at least review the crop type information available through OpenET in advance. And then finally, a reminder that the data from OpenET is the calculation of the actual ET, and it represents ET from all sources. So from precipitation, applied water, access to shallow groundwater. And if you're interested just in the consumptive use or comparing data from OpenET against estimates of ET of applied water, it's important to first calculate effective precipitation and subtract that from the OpenET data first. So if you want to do an apples to apples comparison with pumping records or estimates of ET from applied water, it's really important to provide that correction for effective precipitation. I'll pause there and see if there are any questions before I pass it over to Jody to talk through the user authentication and geodatabase components of the API. Okay, and I'm happy to also answer additional questions in the chat. All right. So with that, I'll stop sharing and we'll pass that over to Jody.
Is it coming through?
Yep, thanks, Jody. Can see
Great.
it.
So I'm starting at the documentation. That was the first link. And so in this we'll answer a lot of questions. So under the getting started, it's going to go over the authentication, which I'm going to talk about in a second, registration, which is getting your token. And then you can see that it's organized by Geodatabase API and Raster API. We also have tutorials, so I'll show you some code snippets, and you can find similar code scripts in this area. And so I'm just going to click on time series really quick, and it gives you all the different endpoints that you can use. It will show you, for instance, if models, what type of models you can choose from. So there's a lot of information in here, but it's a little overwhelming at first. So one of the better places to kind of get going with the API is actually the Swagger UI. Just making sure you can see it?
Yep, we can see it.
Great. So this is a Swagger API, and it's going to have all these endpoints. And again, you can see we have some home endpoints, some time series and metadata. That's the geodatabase or the field view API endpoints. And then down here are the raster ones. So right now I'm going to walk you through the first part, which is getting authenticated. Up here, you will need to press this button and enter in your token and hit authorize.
Jody, would you take just one moment to just show what the auth.etdata.org site looks like and where to retrieve the token?
So I've already logged in. So this is kind of what you will see, but this will take you through logging in and get you a Firebase ID. And are we still manually doing the tokens, Forrest?
Yes, we're still manually authorizing tokens.
Okay.
Yeah.
So once you log into here and kind of sign up, we can then get you a token. And that's at auth.etdata.org. And I believe we're just emailing those tokens to people at this point.
Yeah, and I realize I think your screen for that particular account might look a little different. I'll let you walk through it, and then before we pass it over to Will, I'll show folks what I think most users will see.
Okay.
So
these first endpoints, they kind of help you get started. So this first one, it's just a sanity check to make sure that everything's working, the connection is working, you don't have any blocks maybe by your organization. And you don't need a token for this one, and it will just say, welcome to the API. After you authorize, you can hit the validate token. And that's going to tell you that your key works, everything's working well. You can look at your expiration for your key here. You will have to update it every so often. And so these are just really simple checks to make sure that you've entered in the correct token, it's reading it correctly, and some information about that token. And then once you have authenticated yourself, you can go down here, a really simple check that the database is working are any of these endpoints. So I just want to go change to another screen really quickly and kind of show you a really basic API call for the field view. So you have here is the explore etdata.org. So I'm just going to click on a field. And so I have here, up here is a field ID. So I'm going to go over here to features monthly. I'm going to try it out. And all of these are going to be pre-filled so that they will work. So you don't even have to type in anything if you don't want to. You can just hit execute. But if you do want to do something more specific to what you're interested in, we can do ensemble data ET. You can start changing these different fields. So I'm going to do that and try to replicate what I'm seeing on the field view of the Explore site. So here's the monthly data. And one of the things that I want to point out, so this is one of the easiest ways, but it will also give you this curl command that if you are interested in using curl commands, you can go over into your terminal, paste it in, and you will also get the same information. So I also wanted to show you just really quickly a short little script. And we have, like I said, we have some similar ones on the tutorials. And so this is setting up the parameters for the call. We're using Python requests. So I'm going to run that. And it's going to grab all the data. And then I'm going to put it in this plot using pandas and matplotlib. And you can see that we get the same data that we see for this field on the field view. So this is just kind of a really quick get started with the geodatabase. And then additionally, I'd like to show you a couple things if you need to get something a little more specific. So in here, there is under metadata, you can get a region of interest. So maybe you want more than just the one field, you want an area. So you could go in here, like this is geojson.io. I think there's other areas that you can use. I think we might have a site as well. And you can get the coordinates of a polygon. Enter in those coordinates here, and it must be a closed polygon, else it won't work. And then it's going to give me the field IDs for that area. So that's one way to get, another way to get your field IDs. Additionally, you can also use this feature ID list. And so this is going to enable you to start kind of requesting different things. So we have an area, which is going to be like, maybe you just want a certain size field. The MGRS tile, which is an area. So I've picked kind of the same one. And I think we need to have a link. We will add a link to these MGRS tiles. And down here, I've done the CDL code. And just to show you really quickly, those are also available in the documentation. So these are all the different fields that you can, or types of crops that you can filter by. So down here, I've picked 211, which is olives. I've restricted it to a region. I'm going to hit execute. And it's going to take a while because this is basically looking at all the field polygons. And it's going to show me the olive fields in California in this area. And this is how we get the field IDs that we can then go back up to use for these different time series endpoints. So we have monthly, annual, and then we will also do a couple of statistics on them. We can aggregate either spatially or temporally. And so this is pretty much the geo database. I just want to pause for a second. Does anyone have any questions so far?
Lauren, did you, I saw you had a note there about filtering by CDL code. Did you have a
No,
question
I was giving you guys a high five for implementing that. That's all.
Okay.
So I will go ahead and turn it over to Will so he can show you the raster side of the API.
And actually, before you do that, Jody, let me just quickly share my screen. I think you have a special account. So I think when you visit auth, that looks a little bit different. Share the screen here. I think what most folks should see when they visit https://auth.etdata.org is a screen that looks like this. If you're not seeing that, please put a note in the chat and we'll make sure the API access is enabled for you. So you should see your name, your Firebase ID and the API key with buttons to copy the API and take you directly to the Swagger-based interface for the API. So if you're not seeing something like that, please put a note in the chat. Any other questions for Jody before we move on? You may, Crystal asked a question about if you'd signed up previously, did you need to get a new token? We will need to periodically refresh your tokens for now. That system will become automated in the future. But if you're having any issues retrieving your token, just let us know. And then Lindsay was asking about correction for effective precipitation. If you have questions about that, also please reach out to support at openetdata.org. That adding an effective precipitation data layer to the list of data available from OpenET is on our roadmap for 2022. And then let's see. Okay, and then seeing a couple of questions from folks about access, and we'll take a look at that. And then Crystal is asking, is there an example on the website or in the documentation for the example that you just showed in terms of filtering by CDL code? Is there an example in the documentation?
Yes, there is.
There is, okay. And then for those of you who noted that you aren't seeing the API key, I will work on fixing that while Will walks through the raster API.
Okay, well, thank you, Forrest. Thank you, Jody. Hi, my name is Will Carrara. I am a core backend developer with the OpenET project. I, with Alberto Guzman, co-developed the raster API component of this. So I'm going to share my screen and walk through a few slides, and let me know if this is coming across. Can everybody see my screen okay?
Yeah, it looks good.
Yep.
Alrighty. Well, some of this information's already been covered, so I might quickly go over what we're going to talk about. So what is the OpenET API? Just again, maybe reiterate some of the differences between the raster component versus the geodatabase component. I'll be showing you some of the available endpoints for the raster API, go over a few examples, talk about some of the patch notes recently, and then the 2022 roadmap. So the OpenET API is essentially what is making that Explore website function properly. It's an asynchronous task queue that is built with Earth Engine on top of a very large serverless cloud computing infrastructure. Essentially, it just allows us to sort of automate some of that interface between what a user does on the Explore website versus how that is actually processed from the raw satellite images. So to reiterate quickly, the geodatabase component is just those pre-computed data values for predefined field boundaries across the Western United States. So if you want to retrieve just one of those fields, it's just quickly pre-computed and very fast. The raster component allows for a little bit more of that bespoke data, whether it's a point, a polygon, or multiple polygons. So in this case, you could see on the top that you just get one of those fields, whereas if you're interested in more a general area, that's what you'll be using the raster API for. Now, for the raster API, there are 4 different categories for the endpoints. Time series is just going to return JSON or CSV data types for whether it be looking at a specific longitude, latitude coordinate, whether it be a comma separated list of longitude, latitude coordinates for a polygon query, or whether it be a shape file which contains multiple polygons and you want to extract data for each of those in a specific region. Our export functionality will export a composite geotiff. It will export individual stacks of geotiffs. And we also have, for checking where those files exist, when you export a file, we automatically set up a Google Cloud bucket for you. So your user has sort of a storage container already predefined for you. So you can reach, what files have I exported? How do I download those files using that all files endpoint? Lastly, we have the metadata endpoint and the visual endpoints. The metadata allows you to peek inside some of the source OpenET collections and to find out additional information. Maybe if you're more interested in some of the inner workings of a model that you're interested in a specific region, you can use this to see if certain, in my area, has there been new data in the last, n number of days, and you can see the most recent update to data in your area. The visual endpoints allow you to kind of use OpenET data to sort of quickly generate like a nice animation of, a time series of between, maybe for a year's worth of data to see how your region's changed. And you can apply whatever type of color filters you like, a specific color ramp, and that's fully customizable. And Tile ID is just a tool that you can use as a developer to create sort of custom maps in the web. So I'm going to quickly go over a live demo here. So Jody's already talked about the documentation and went over the different endpoints. And we see here in the raster subsections that you will, for each time series, point, polygon, multi-polygon. One of the things that the users have asked for is some example outputs in that documentation. So we've done a few updates, fixed some parameters. So you'll just see it quickly, what does this JSON output look like for a time series, whether it be or a CSV, and you'll be seeing that for each of the different endpoints here, what some example returns look like. So without further ado, you should again be seeing this type of login screen when you go to auth.etdata.org. If you don't see that you have an API key right here, please just put your name and the email that you use to register in the chat, and then we will go through and update that permissions for your account. So you can copy your API key, hit Access API, which will bring you to the Swagger, sorry, not Swagger, it's the OpenET API, this is a rebranded page. So I've already gone ahead and authenticated, and I'm quickly going to go through a couple of the endpoints here. So similar to the geodatabase, you'll see some parameters sort of overlap. You can click this try it out button, and you can enter various models from that you'd be interested in. You can say I'd like a specific variable, different time ranges, your reference ET source, whether that be GridMet for the CONUS or Spatial SIMUS, which is specifically for California if you're in that region. You're going to see sort of a provisional value, whether you want the most recent data that's still being processed. There's going to be a units parameter, which just tells you whether you want metric units in millimeters or inches for English, and then your spatial coordinates, and here longitude and latitude. So I won't overlap this too much, but when you execute a query, you're going to be seeing a few different things down here. You'll be seeing this curl request, which again just can go directly in the terminal, sort of a request URL. This will help you format, if you're doing things programmatically, format those requests so that you can make them properly. And then the response body. OpenET API is really nice because it just is a very distilled version of what like a more complicated process when it comes to coding. So you can download these results, copy and paste them, and you'll see that there. So one last thing to note here is that some of these endpoints will be either a GET or a POST request. In some of our more recent updates, some of the raster endpoints have changed to POST requests. This is because when you make a POST request, you don't have a character limit when making that request, meaning that you can include more complicated geometries that might be longer. So it's very similar when you make that request, that again, you're going to be seeing some type of response, etc. Now, if you maybe enter incorrectly, a parameter that doesn't work, what will happen is you'll be seeing some JSON error codes. Whoops, that should not happen. But you'll be seeing an error message, which will result in saying, hey, this doesn't exist. Please try to requery. Now I'm going to go ahead and go down and talk about a little bit about the multi-polygon endpoint here. Now this one's a little bit more complicated. So the multi-polygon endpoint allows for a much larger scale retrieval of OpenET data. You may have a shapefile that covers a very large regions. Now we do impose some limits here. We can't successfully export all of California very quickly and tie up the task queue for other users. So when you are using the multi-polygon endpoint for each individual shapefile asset that you pass in, these are going to be limited to a 20 megabyte file size and 10,000 individual polygons. So depending, you'll have to kind of play around with your shapefiles to be able to potentially chop them up into smaller bits if you're querying large regions. But we ask that because there are some inherent computational limits for what we need to do to process the data. So if you pass in a shapefile that maybe looks like this and you have very large regions, you have the option to retrieve time series data for each of those polygons. But if you, in this case, they're not really chopped up very cleanly and you want to add some additional masking, maybe specifically for irrigated lands within that, the multi-polygon endpoint does support that type of parameter. And so it would look something like this, where you can add this type of masking in where you're really retrieving data, which just overlaps the white areas and the red areas. So where those intersect and overlap, you're going to be retrieving data specifically for those regions. So I'm going to go over some of the patch notes and some of our recent improvements to the raster API. Now we have added daily data to the raster API. We have two methods of retrieving this. One is this sort of a very quick, fast way of doing that. And that's going to be what's the default. This is a less computationally intensive way to be able to quickly retrieve and do those reduced region calls. The second is this sort of more computationally expensive pixel-based interpolation. Now, I should mention we are doing a lot of testing, and this is still in beta as we fine-tune these retrieval methods to make sure that the data correctly lines up when retrieving monthly and daily data. So at this time, a lot of that testing is still being done. We've added precipitation retrieval from the GridNet product. From a lot of users, we've also heard about some different errors, some bug fixes with the HTTP error codes not being returned properly. You could make a bad request and get a 200 successful response code, and that doesn't make any sense. So we fix all of that. We're adding in additional shapefile validation. We've done a lot of performance and optimizations to the just core functionality of the API and the serverless infrastructure. We've updated the documentation. When querying in California, you're going to have native CMS support for the reference ET. So if you're on the Data Explorer and you query something that is completely contained in the state geometry, it will use that natively if you do not specify what the reference ET source parameter should be. We've done some additional post-processing bug fixes for some of those larger exports. There was a bug with the shapefile masking not working properly, and that's been fixed. We've updated the code examples to sort of reflect the latest changes with the API and include additional parameters. We did see some users reaching their quotas sooner than expected. And there were just a couple bugs in there, which we fixed. And then lastly, we're implemented some internal mosaicing when it comes to certain polygons which lie on the region of two different satellite images, and some weird things can happen. And so a lot of that's been fixed. Looking ahead, for 2022, in this January, we've really implemented all that daily data and added that pixel-based support. In mid-February to March, we're going to be adding an additional satellite. The successful launch of Landsat 9 will give us a lot of additional data, which is we're really looking forward to playing with. In that April to May period, we are going to support the independent use of Google Earth Engine accounts. So currently, when you make a request, you have a specific quota tied to your account. Now, if you're going to be doing a lot of different requests, you can create your own Earth Engine account and be able to use that and not tie up your quota as much, which would be really beneficial for some of those power users. Between June and July, we're looking to implement our forecasting for time series. So this is something we've been doing a lot of testing on to be able to look at different approaches and find, for different variables, what is the optimum way to accurately forecast data. So we'll be implementing that in the middle of this year. And then when it comes to August and beyond, what we're really looking to see is how the first part of the year develops, what feedback, what are the requested features from different users, and what will we want to really be digging into then based on how the first half of the year goes. I really want to say thank you to all of our developers, to everybody who's been beta testing. I mean, I understand that it can be so sometimes frustrating to write code to test something that sometimes will break or change or update. And everybody's feedback has just been phenomenal and so helpful. And it's helped us build a genuinely good piece of software. So thank you to everybody who's been with us. Thank you to everybody who's about to start that journey. Lastly, questions.
Thanks so much, Will. Really nice overview. Questions for Will? And I'll also say I've been trying to keep up with all of the messages in the chat, and I think I've now let me just hit save on the very last one for Josue. And great, there it goes. So I think everyone, I should have either refreshed your key or enabled API access. So if you're still having issues, let me know. Let's see, questions. Will, there was a question about how to check quota status, and the size of the quotas.
Absolutely. So in that Swagger interface, there's actually an option at the top, and I can show everybody really quickly here to check what is your user quota. So right here, there's going to be it's /home user/quotas. You can just hit try it out. Since I'm already logged in, it's going to show that these are my specific quotas for the various things that we keep track of. Does that answer the question there?
Other questions? I'm looking in the chat here.
Is there documentation of the quotas, what they mean?
Yes, so that actually needs to go in the latest round of updates, which we'll be pushing later this afternoon. So Forrest, I think you can probably do a better job of explaining, the acre months versus acre years really quick, and then we'll be adding some formal documentation in that API section.
Will, would you mind just showing a sample quota for a user, and I can talk through how to interpret it?
Yes, of course.
Yeah. Okay, so yeah, we'll add that to the documentation, but the quotas are set. So acre years would be total number of acres times total number of years retrieved. Same thing for months and days. We have different quota limits for each of those, just because, of course, you'll have different time steps required to retrieve data for the same area at daily, monthly, and annual time step. We have a limit on total data retrieved, because there are outbound data charges. So just to keep track of the total volumes of data retrieved, both per month and per day. The access year so the access year start and access year end, those are the years for which each user is allowed to access data. And then the max acres is the maximum total area, maximum total acreage of all queries allowed per user for the testing accounts. And then max polygons is the maximum number of polygons that can be retrieved in each month for each user. And as Will mentioned, we'll refresh the documentation and include that information.
Are the monthly quotas refreshed every month?
The monthly quotas are,
Everything's refreshed every month.
yeah, everything. Yeah, so everything gets refreshed monthly.
And there is also a rate limiting, which people probably haven't run into, but you can only make so many, like 150 calls per day.
Thank you.
And then Chelsea was asking, with a shapefile that's 115 acres, but the raster time series multi-polygon endpoint returns an area of 148 acres.
I can answer that one. So the way that the area is calculated in the multi-polygon endpoint is going to be an approximation based on the number of pixels contained within that shapefile. So a lot of different shapefiles, you can attribute a separate column of area. So if you trust exactly, like I know that it is 148 acres for sure, you can just add that in the include columns parameter for when you export, and just ignore what the API will return. It might Again, there's going to be a little bit plus or minus a little bit because we calculate each pixel at 30 meters. So you might, it's going to, again, best way to do it would be to include that attribute.
Other questions?
Hey, Will, thank you so much for answering my question. I have a follow-up.
Yes.
So it's the 30-meter pixels, but am I for the ET mean for my time series data, am I looking at mean ET for 148 acres or for my actual shape file, like if it was clipped, if that makes sense?
Yes, so nothing is happening to that shapefile. So what it is calculating is based on the shape, the various shapes that are inputted there. The area calculation is again just it's kind of an approximation based on that. But what is calculated is what the user has inputted. So nothing has been clipped.
Other questions?
Will, we should probably add something to the documentation about how the area is calculated, because I can see a lot of confusion with that. So we
That's
should add
correct.
some, yeah.
Yes, I'll make a note of that right now. And for the next update to that documentation, I'll include a little bit about the shapefile, the multi-polygon area calculation. Okay.
And other than John Ernest, it sounds like we might have some issues. John, we might just need to clear your cookies on the auth.etdata.org page and reload it. Anyone else having problems with their API keys? Okay, good. Ali is asking, is Landsat 7 used? Yes, Landsat 7 and 8 are both used. Could you clarify what you mean by how are the bands handled?
Yes, there are missing bands in some of the Landsat imagery, Landsat 7 imagery that we have discovered for different areas. And we are wondering if you're seeing that or you're having to deal with it or having to handle it.
Let us know if there are particular locations or issues. What we'll do is anywhere where the bands we need to run all the models are available, the models will run using Landsat 7. If data is missing, either due to cloud cover or data quality issue, then we will simply omit those scenes.
The
Sorry,
scan lines, I
should,
think.
Yeah, I should correct and say strips, not bands. Okay.
Yeah, the scan
You
line
mean the
issue.
scan line correction error.
Yes.
So the way that's handled is going to depend on the way that's going to vary based on the way you interact with the API. So for the monthly data, what happens is for each pixel, we do the time integration at the pixel scale currently. So we will use all available data points for a particular pixel, calculate the daily scene assets and the daily fraction of reference CT, and then perform the time integration at the daily time step, and then compute the monthly products. If you are accessing the raster API to retrieve daily data, there are, as Will was talking about, there are two ways to retrieve the data. One, to provide a polygon, and what the raster API will do is calculate the average ET and average ETOF for the polygon at each of the days for which we have a scene overpass, and then perform the daily interpolation on those mean values. For homogeneous agricultural areas, that is what I would recommend using. So for irrigated agricultural lands, for fields that are relatively uniform, that would be the best way to retrieve daily data. You may see an offset in between the monthly values computed, retrieved directly from the monthly assets because of that Landsat 7 striping. For natural land cover types, areas with a lot more spatial variability, for retrieving daily data, it would be better to use the pixel-based interpolation in the raster API, since that's going to probably do a better job of filling for areas with more spatial variability in the data.
Thank you.
We're really looking forward to Landsat 9 and not having to worry about that problem anymore. There is, as those gaps have gotten larger and larger, there's just no perfect solution for filling them.
I see a question in the chat about when making an export raster request, you get a download link, and how long does it take for that to be processed and stored? It's an excellent question. I apologize, I didn't touch on this earlier. This is going to depend on a few different factors. If you are making a request that is of a relatively small area, this will take just a couple minutes to be exported and post-processed, and you'll see that show up when you use the all files endpoint query. For very large areas, and when retrieving, at a daily data time step, this is going to take significantly longer, and you could have a wait time up to 24 hours if retrieving 50,000 acres over 2 years of daily time interval. It will take about 12 hours potentially to be fully exported and post-processed. But a good way to check that programmatically is just to every so often, maybe every few hours, query all files and say, hey, did my export file name show up here? If not, check again in a few hours.
And we're also using a shared resource with Earth Engine. That's where we're doing the processing. So it also depends on their queue. It has been really fast the last few months, but that's another factor. So depending on the size of your query.
Yes.
Do you expect the addition of the Landsat 9 to improve the latency of the data?
Not immediately. So the data latency, we did have to make some hardware upgrades. The geodatabase was getting so large. We actually had to upgrade some of the hardware to make it easier for us to update the data. That's actually been the barrier. Are you talking about through the API access or through the Data Explorer?
It's just through either.
So don't expect the addition of Landsat 9. Well, latency between the availability of data and the time of satellite overpass, expect that to be consistent between Landsat 7 and Landsat 9. What should happen is we expect to see more scenes past the QA/QC flags. So hoping to see, expecting to see more frequent updates and fewer scenes that are flagged due to data quality issues. So in that sense, expect average data latency times to decrease. And then we're working on implementing a near real-time product where we'll be processing the data from the top of atmosphere reflectances and generating a preliminary product with a target availability of within 24 to 72 hours from satellite overpass. So that's another element that we're working to add here in 2022.
Okay, thanks.
And there was a question that I missed earlier about a question about a high bias in the San Joaquin. That has been reported to us by some of our agricultural partners in the Kern Basin. That's something we are investigating, and a number of folks have flagged that the ET estimates from multiple models and from the ensemble value seem high relative to their records of applied water and precipitation. So that's something we are investigating, but that's the type of feedback we're looking for. One thing we seem to be hearing is that mostly pertains to well-established mature citrus and almond crops. So if you're seeing differences for other crop types, please let us know. Other questions or feedback? Julie, yes, we will be sharing a link to the recording. Ben, if you're able to stay on for a few minutes afterwards, we can try to troubleshoot your API key. And if not, send us a note. We'll follow up with you separately. Okay, I'll pause just for one more minute, see if there are any last questions or feedback for the team. And if not, I'll say thank you so much to Jody and Will for a really nice walkthrough. Thank you to all of you for taking the time to join and for being part of the API working group. I really appreciate, as Will mentioned, we're grateful for your assistance with testing and identifying issues with the documentation or helping us find bugs. We couldn't do this without you, so thank you so much. In terms of next steps, as Will mentioned, we'll be working to add support for users Earth Engine accounts to help us support scaling of the API as we work towards the public release of the API. Working on finalizing the addition of the daily data along with the near real-time, low latency and forecasted daily ET that I mentioned. Again, I'll put the support link in the chat. Please do send questions, feedback, comments to support@openetdata.org. Put that in the chat. So that is the best way to reach us, and that will allow us to distribute the questions to the right folks on the team. We will schedule another full API working group meeting, likely sometime in March, so in a couple of months, just to review any additional updates, improvements, and get input as we work towards the public release of the API. That I'll say thank you again, and happy to stay on for another 5 or 10 minutes in case there are other questions or things folks wanted to ask. I see those so let folks drop off. I see there's one question about OpenET versus Calcimitar. I'll just say quickly, those are like Calcimitar provides estimates of ET using a crop coefficient approach. So it takes an approach where it looks at the total acreage of a crop within each region, and then assumes uniform well-watered conditions for all of that acreage, and then uses a crop coefficient combined with the CIMMYS data to compute ET. So it's a estimate of ET under well-watered conditions, and probably would generally be characterized as representing an upper limit on expected evapotranspiration from applied water, which is a really useful number to have. OpenET uses satellite-driven models to calculate actual ET, and again, the ET from all sources. So that can be ET from applied water, whether that's surface water or pumped groundwater, ET from precipitation, and even access to shallow groundwater in riparian systems or other areas with shallow groundwater, shallow aquifers that can be accessed by some of the deeper rooted crops. So I would recommend using them together, since they provide different types of information. Okay, let's still a few folks left. So before we troubleshoot your account, I'll just see if others had general questions or suggestions for additional features or things to add to the documentation.